51 says to the nearest whole number, what is the mean of the list? So we know we're looking for the average. The list of numbers is 41, 35, 30, X, Y, and 15. It means we don't have two numbers. It has a median of 25. So I have 6 numbers here. The median is going to be between them. And it has a mode of 15. So I only have one 15 in here, so I know I have to at least have another 15. So I'm going to cross out this Y and put a 15 here. So now I have one extra number that I have to figure out. I could, if this is also 15, which includes the mode here, then my mean, if I were to use 15 there, would be 41 plus 35 plus 30 plus 15 plus 15 plus 15. Then I would divide that by 6. And my mean is 25, but the median of 30 to 15, so I do 30 plus 15 divided by 2. That is not the correct median. I need 25 as the median. So if I'm looking at this list of numbers and I have to figure out this number, what does this number need to be? Well, it can't be bigger than 30 because then my median would then be bigger than 30. So it has to be smaller than 30. So I can use 30. I need to get this number to be 25. So if I want to go between 30 to go to 25, I could go down to 20 because 30 plus 20 divided by 2 is 25. So I can actually use the number 25 instead of 15 here. So I'm going to go grab this. I'm going to type this in as 20 as my number because that way 25 is in the middle. So X was 20. So if I look to see here, I would find 30 and 20. 30 and 20, the median would be 25. Then I'm going to divide this by 6, and we get a mean of 26, which is answer choice C. 52 says, you are given the following system. Okay, so we have a system of equations. So y equals x squared, rx plus sy equals 10. So we have 2 missing letters, R and S, that we don't know what they are. And down here it has, for which of the following will there be more than one solution with real number coordinates for the system? So if I'm looking at a system of equations, I do know that y is equal to x squared, so I can rewrite this as rx plus s times x squared equals t. Well, now it's starting to look like a quadratic. So if I actually put this as a quadratic of sx squared plus rx minus t equals 0, now I have a quadratic, and now I can determine how many and what type using the discriminant from the quadratic formula, which was just b squared minus 4ac. And if you notice, this is in that format. Your b squared minus 4ac. My discriminant to be more than one real has to be positive, and it cannot equal 0, so it has to be bigger than 0. So the b value is actually r. So r squared minus 4 times a would be s, and the c would be negative t. So coming through here, it's got to be greater than 0, so I can get rid of h, j, and k. So it will be r squared. This one says plus 4st. Well, if we look at this, this is negative 4 and negative t. So that becomes positive 4s positive t is greater than 0. So the answer is F. (53) says the third and fourth numbers, or third and fourth terms of an arithmetic sequence are 13 and 18 respectively. So that means that the third term is 13, the fourth term is 18. That's what respectively means. What is the 50th term of the sequence? Now, I'm not going to try and do arithmetic sequences, the whole version of it. I do know that it just means I'm adding the same number every time. So I'm going to add 5. So every time I add 5. So I'm just going to use my calculator to do the pattern. So I start with 13 and I add 5. So that gives me my third. So this is my third value, and this is my fourth value. So I'm going to add 5 again. This is my fifth. And because I've set a pattern here, my calculator has set the arithmetic sequence, I'm just going to keep going until I get to the 50th term. So again, this was the third, this was the fourth, this is the fifth. I'm going to press enter. This is the 6th, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50. You do have to be careful to make sure that you are watching it as it's going and paying attention that it is actually moving as you press enter. So the 50th term is A 248. And that was just understanding that it's just adding and I'm using the calculator. 54, the question is just which one. That doesn't tell me anything, so let's read the question. One of the following graphs in the standard xy coordinate plane is the graph of y equals sine squared x plus cosine x over the domain of negative pi over 2 to pi over 2. Okay. Well, sine squared of x plus cosine squared of x, that's actually the trig identity. This comes from Pythagorean theorem of a squared plus b squared equals c squared. This is sine squared x plus cosine x. Sorry, so sine squared x plus cosine squared x is actually just equal to 1. So we're really just graphing y equals 1. That's all this graph is. And if I were to double check what y equals 1 looks like, y equals 1 is just a horizontal line. That means the answer is H. And by the way, you can cross out F and J automatically because it does say the domain, which is the x's, go from negative pi over 2 to pi over 2. So only G, K, and H could have been right.